Good afternoon to everyone. So today class is layers of the atmosphere. Okay. So here there are 5 major layers in the structure of the atmosphere. It is depending upon so what criteria temperature in variation of criteria, right? So first of all we learn about temperature variations of the layers. So what you observe here, so this temperature on one axis on the base and altitude, right? Base and altitude. So what we see with altitude, what happened to the temperature? So you look at this particular place, it is tropopause, right? Tropopause, this one, right? A troposphere, this one. So what happened? The temperature actually goes from positive to negative, right? So till this particular transition zone, so that is tropopause, right? So the word itself, it falls here where is a mixing zone where there is a pause happening. So what happens from this pause again, again this temperature, it has started to rise in stratosphere, right? So for some time, it remains constant here, this particular place. So, and then again starts rising when we go ahead in what? So in attitude, in stratosphere, right? So that is important. You remember this word. So then what we observe again is again here, it remains constant here, this place, right? For some time only. So which is the stratosphere, right? So, and then again it starts decreasing the mesosphere, right? So that is negative 80 degrees Celsius at the upper boundary of the this mesosphere, right? So it goes to the minus segment, and this is the plus segment, right? This is minus segment and this is plus segment. So then in mesosphere, so what happened the mesosphere? So mesopause, right? This mesopause is the transition zone. So between mesosphere and thermosphere, right? Mesosphere and thermosphere. So again here, sometimes it remains constant here, right? So it is something 2 degrees, right? 2 degrees Celsius. So, and then Again, it goes on increasingly 82 degrees. 8 plus 2 degrees, 82, right? So 82 degrees Celsius to 1200 degrees Celsius up to here, right? And further, when we go to the exosphere, we find the differences. So what we see is here, you see this one, right? This one, right? This looks like sigma, right? So sigma is, so it's kind of situation in this diagram. So this is the simple diagram. If you can remember, this looks like sigma symbol, right? So from the troposphere to exosphere, the outer sphere, how does this isotherm look like? This line, right? So which we say this looks like a sigma. So what happened here? There is a change in temperature across the all these 5 layers with a attitudinal factor. So that is where the structuralization of the atmosphere is important. So on the basis of this temperature, so that is where we say those these 5 layers, right? 5 layer structure are the stratified structure of the atmosphere, right? So the temperature can be divided into layers based on its temperature moving upward from ground level. So these layers are, you see here, troposphere, stratosphere, mesosphere, and thermosphere, lastly exosphere, right? So first one is troposphere. Tropos means change, right? Tropos means change. So it is the first layer of the atmosphere. So it is also the one where we are living in this layer. So this layer gets its name from the weather that is constantly changing in mixing of the gases, right? So in this part of our atmosphere only. So this layer is the lowest and the closest to the earth surface, right? Earth surface. You see here. So this is our globe. This is our earth, right? So this is close to the earth. So on average, the troposphere, it extends from the ground to about 12 kilometers or 7.5 miles above mean sea level, right? Above mean sea level or 33,000 feet, right? So the air never static in this layer. It means in this layer, there is a lots of changing happening. So that's why it is also called changing sphere, right? What is that? Changing sphere. So troposphere is dynamic sphere. So where lots of changes are happening in this sphere only, right? So in this layer where lots of atmospheric phenomena keeps happening here. So all weather conditions changes, it occurs in this particular place. So most of the clouds, you see here, this white one. So most of the clouds appear in this troposphere because 99%, right? 99% of the atmosphere's water is found here only, right? So that's why clouds are appear in this troposphere only. So the troposphere contains about 75% of all of the air in the atmosphere and almost all of the water vapor which forms clouds and rain, right? So that we should understand. So in this layer, air is made up of approximately how much? 78% nitrogen and 21% is oxygen and 1% is other gases. So including organs and water vapor and also carbon dioxide. So, and part of this from the that we observe here what is happening. So the temperature decreases as you see this graph, right? This, right? So the temperature decreases at the rate of 1 degree Celsius for every 165 meters. So, and so many people are write it into 6.5 degrees Celsius per 1000 meters. So that is for 1 kilometer. So it is an average value. So you can take either of them, that's okay. So that is also known as lapse rate, right? What is that? Lapse rate, LAPSE, lapse rate. So now remember there is a temperature decrease with the increase in altitude in troposphere, and this is also called the normal lapse rate or environmental lapse rate. So that is ELR, environmental lapse rate, right? So this is the troposphere. And then next one is stratosphere. Second one is stratosphere. So the strat means layer, right? So this layer of our atmosphere has its own set of layers, right? So the boundary between the stratosphere and the troposphere is called tropopause. Where it is? This one, right? So this one troposphere, this one stratosphere. So this line is called tropopause, right? So it is the region where aeroplanes fly here, right? Aeroplanes. So because this less turbulent layer provides a smoother ride. So the jet streams flows near the border between the troposphere and the stratosphere. So the lower boundary of the stratosphere is called the tropopause, right? So the stratosphere layer, it extends from the tropopause to about 50 kilometers. That means 32 miles. So above the earth surface, right? So this layer contains a thin layer of ozone molecules which forms a protective layer and absorbs harmful ultraviolet radiation from the sun. So this layer is very dry as it contains little water vapor, right? So that is the water vapor content is less. So the stratosphere actually gets warmer the higher the trends of rising temperatures with altitude. That means air in the stratosphere lacks the turbulence and updraft of the troposphere beneath. So in this layer, the temperature again start to increase right after being constant. That is minus 2 degrees Celsius. So the high altitude weather balloons flying into the stratosphere only. So for monitoring atmospheric conditions and also climate research. So air is roughly 1,000 times thinner at the top of the stratosphere than it is at sea level. So because of this, jet aircrafts and weather balloons reach their maximum operational altitude within this sphere, that is stratosphere. So this layer provides some advantages for what is that flights. Why there is an advantage to fly in this layer? Because the stormy weather is not there. So the stormy weather actually ends at the tropopause here only, right? So above this tropopause, there is this layer where. So there is an advantage of flying for these flights, right? So the ozone layer is found in this layer. This is this ozone layer. Remember this. So that is absorbed, ozone layer is absorbed UV rays and safeguards it from harmful radiations. Okay. So the lower stratosphere has ozone sphere, right? Ozone sphere. So, and what it is, the altitude of this ozone sphere, it varies from 15 to 35 kilometers from the tropopause, that is here. You see this? So from tropopause to the upper stratosphere, this is 15 to 35 kilometers, right? 15 to 35 kilometers. So the variation. So we can say it is majority the lower portion of the stratosphere where this zone concentration, right, is there. That is ozone, right? So the infamous ozone layer, right? This sorry. So in this ozone layer is found within the stratosphere, right? So in the atmospheric zone exists in two forms. That is, first one is good zone, right? Good zone, and second one is bad ozone, right? Good ozone and bad ozone zones. So bad ozone formed in the atmosphere, that is troposphere, right? So that harms plants and animals. So good ozone protects us against dangerous ultraviolet light out to the our atmosphere. So good ozone is found in the upper part of the atmosphere. So that is stratosphere. So and it acts as a shield absorbing ultraviolet radiation from the sun, right? So ultraviolet radiations, that means UV rays. So these rays are highly injurious to living organisms since DNA and proteins are living organisms preferentially absorb UV rays. So and its high energy breaks the chemical bonds within these molecules. So the thickness of the ozone in a column of air from the ground to the top of the atmosphere is measured in terms of what is that? DU. DU means Dobson unit. D means Dobson unit, right? So this is the stratosphere. The next one is mesosphere, right? So meso means middle, right? Meso means middle. So this layer is located above the stratosphere, where above the stratosphere, and below the thermosphere, right? Above stratosphere and below thermosphere. You see here, where is the stratosphere? This one, right? And thermosphere, this one. So this is above stratosphere and below thermosphere. So this is called mesosphere, right? So it is the coolest layer of the entire atmosphere. Remember this, coolest layer. So it is the third layer in the our atmosphere, and its variation is from 50 kilometers to 85 kilometers. So by 80 kilometers, it reaches up to about 100 minus 100 degrees Celsius temperature. So about 80 kilometers, it becomes now minus, right? So that is important. So minus 100 degrees Celsius, right? So that is about 80 kilometers. It is become minus. So most meteors here, you see here, this one. So meteors burn up in this atmosphere only. There is this in mesosphere. So the meteors fall and burn maximum in this layer itself. So this transaction boundary which separates the mesosphere from the stratosphere. So that is called, what is the stropopause? Here. Right? Stratopause. So in the mesosphere, there were 8 molecules to absorb incoming electromagnetic radiation from the sun. Right? So this is the mesosphere. So the upper limit is called mesopause. Right? This here, you see here, mesopause. So thermo, next one is thermo. Thermo means heat, right? Heat. So this layer has extremely high temperatures in located above the mesosphere and below the, what is that? Exosphere. Right? So the boundary between the mesosphere and the thermosphere atmospheric regions, so that is called, what is that? Mesopause, right? Mesopause. So it is the coldest parts of the Earth atmosphere. So the thermosphere extends from the mesopause, right? That is to 700 kilometers. You see here, 700. 700 kilometers. It means 435 miles above the surface of the earth, right? So the thermosphere is the thickest layer in the atmosphere. So only the lightest gases, mostly what is the oxygen, helium, and also hydrogen. So these gases are found in this layer only, right? And so you see here, so radio waves which are transmitted from the earth, these are reflected back by this layer. What is that layer? Thermosphere layer, right? So the thermosphere has another further bifurcation where we say this is called, what is the ionosphere. 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 Right? So this one. It has electrically charged particles ionized by cosmic and solar radiation. So in the ionosphere, ions are there. The charged particles are plus and minus, right? So basically, these charged particles are the important factors which are called ionosphere in the lower thermosphere. So which actually leads to this radio wave transmission, right? So it helps us where these charged particles, the ionosphere, reflect back and it leads to the radio waves, right? Radio wave communication, it helps us in the waves, right? So the temperature increases with height, right? So the aurora, you see here, aurora. This one, aurora, and satellites. So the aurora and satellites mostly occur in this layer. What is the in thermosphere layer? So aurora is a natural light, right? Aurora is a natural light display in the sky. So particularly in the high latitude regions. So that is caused by the collision of energetic charged particles with atoms in the high altitude atmosphere. So this is where the charged particles or ionization happens, and that is where the flash of radiations in different kinds of color streams, right? Different types of color streams. And also the satellites for communication have been placed in this layer. So that we see here, right? So that is important. Then next we are going to exosphere. Next, exosphere means exo means outside. It means outside. So the exosphere, it represents the outermost layer of the atmosphere, right? Exosphere, outermost layer. So it extends from the top of the thermosphere, that is to 10,000 kilometers, means 6,214 miles. So above the earth surface. So in this layer, the ozone, where atoms and molecules escapes into the space, is mentioned as the exosphere, right? So the International Space Station, right? Space station orbit is also in this exosphere, right? So troposphere completed, stratosphere completed, and mesosphere completed, thermosphere, and lastly exosphere, right? So this is the 5 layers of the atmosphere. And catalytic ozone creation and destruction. So you see, first one is natural ozone cycle. You see here, natural ozone cycle. So when we say natural ozone cycle, what happens here? So O2, right? So oxygen, which is given, which is uh, oxygen, and it reacts with the UV light, right? React with the UV light. So that is ultraviolet radiation. It breaks into the oxygen plus oxygen. So that is separate O, right? That is separate oxygen, separate oxygen. So that is called O2 plus ultraviolet radiation. It breaks O plus O, oxygen plus oxygen, right? So now this one separation uh, O plus O. So this oxygen, right? Oxygen actually attaches itself to the oxygen, right? O2 plus oxygen. So, and it becomes O2 plus O equal to O3. So which is what we commonly call ozone. So that is where this UV is important here, right? So O plus O equal O3. So O3 plus UV again here. See here, O3 plus UV ultraviolet radiation again gives you one oxygen and one O2. So this is a simple chemical equation, right? So what you observe is the role of this ultraviolet rays here. So the ozone in the stratosphere is continuously being uh, made and broken by the ultraviolet light in the ozone oxygen cycle, right? So after introduction of chlorofluorocarbons, right? So and then if chlorofluorocarbons are there, then we see these ozone holes happening here, right? So why? Because remember, these chlorofluorocarbons react with what is that? Ultraviolet rays, UV rays, right? So and it forms different byproducts, that is chlorofluorocarbons and independent charged particles, that is ion species, the chlorine and others, right? So chlorofluorocarbons plus ultraviolet rays is equal to chlorine and chlorofluorocarbon. So what we see is this chlorine, right? This chlorine plus O3. It gives, now we see different kinds of molecules formations, right? ClO plus O2. So what happened? This ozone is actually broken by this particular chlorofluorocarbon. So chlorofluorocarbons breaks this zone. What we see? Cl plus O3 equals ClO plus O2. So in this particular equation, right? So when the ozone is broken, it means ozone's concentration, being destructed. So in the formation and depletion, so these are both important factors, right? So if ozone is being destroyed, what will happen? So this ultraviolet factor, which is used to be neutralized here. So this UV factor, which was earlier neutralized by ozone, is now actually coming to the ground. So, and that where ultraviolet radiation is harmful for the human beings and also animal life as well as on the earth surface. So, this is the whole idea of ozone depletion and ozone substances, right? So, ozone depletion, I will tell next PPT. Wait for 1 minute. So Antarctica hole in ozone depletion, right? So first of all, we're going to polar vortex, right? So what is this polar vortex and why it was in the news in the year of 2019, and what is it is important to know about this polar vortex. So these are two words, right? Polar plus vertex, right? So what is this vertex? So R about N, where it is coming from, right? So vertex is basically, this is whirling, right? Vertex means whirling. So whirling action, right? And it means something which moves in a circular motion. For example, when you take lots of water in your bucket or your kitchen sink, any place, right? So you can try and keep whirling, right? So what happens? There is this wall created, right? So this is a wide wind, right? Wide wind and wide pole, wide wind and wide pole. So that is created even in your washing machine. You can find it out, right? So that is called vortex. So it is a whirling action. So now what is this whirling action and how it is related to polar areas? So that is where this creation of polar vortex happens there. So next is polar, right? Polar, which means anything related to the North and South Pole, right? North and South Pole. So let's understand. So this concept in terms of this entire climatology and its impact on the entire climatology. So first one is, so the polar vortex. You see here, polar vortex is a largely the area of low pressure and cold air, right? Low pressure and cold air. So now the first line itself, this one, it seems to be very contradictory because we have learned in climatology that low temperature, right? Low temperature is associated with warm air, right? Warm air. So what is this? So this low pressure and cold air, so how it can be? So let's understand, and it is basically where the area itself is clear, it is the polar area. So it will have cold air, right? Cold air itself. But why this low pressure then? So let's understand and clarify this point, that is low pressure area, right? So, but it is cold area surroundings the Earth, north and south poles, and this is referred to as the polar vortex, right? So, actually, there are two vortices on the Earth, right? So, first one is southern hemisphere, right? Southern hemisphere, and second one is northern hemisphere. So southern hemisphere is in over Antarctica. So in northern hemisphere is in Arctic region, right? Over Arctic region. So the northern hemisphere polar vortex is the strongest. Remember this word. This is strongest. So the northern hemisphere is about 60.7% is water and 39.3 land. And the southern hemisphere, it is about 80.9% of water and 19.1% of the land. So the term vortex basically it is what clockwise or counter clockwise, it is depending upon the northern hemisphere and southern hemisphere. So in northern hemisphere, so it is anti-clockwise, right? Anti-clockwise. And in southern hemisphere, it is clockwise, right? So this kind of wind movement, it is very fast wind movement. It happens at the where poles only. So specifically in the stratosphere belt, that is upper atmosphere, right? Upper atmosphere. So here this is important. Remember this. So what happens during winter in northern sphere? When during winter in the northern sphere. So now it is winter in northern hemisphere. When we say, it means sun's movement is southwards direction, right? So this is oscillation that is leads to this. So the polar vortex becomes less stable and expands in the further. If we say this oscillation, right? So this area, if this expands, what will happen? This cold air will come to these lands, right? Cold airs come to these lands, right? And it will bring lots of chilly winters, negative temperatures. So this is why it was concern for many of the countries like Canada, US, right? So that this keeps happening in certain years where there is this polar vortex migration to these land areas, right? So this is important. And that how this entire polar vortex is formed, how it functions, why it is important. So it is in new concept, no, right? No, it is not new concept. So first time it was discussed even in a back as in the year of 1853. 1853 in an article that is Living Age, where it was discussed as a fact that so this is also happens. So this kind of phenomena is there where you have upper atmospheric circulation. So which kind of this whirling wind which is there at the pole. So now let's discuss this in terms of conceptualization and formations. Yeah. So now so many people get confused. What is that? So how this low pressure, that means LP means low pressure. Low pressure system is formed in these polar areas, right? This one. So why this polar vortex is created as a low pressure system, and how even if there is so much of cold air, this cold air. So let's understand what happening here. So if you observe what is happening in this, so this is that line which is called tropopause, right? This one. So which is about this 12 to 15 kilometers, right? 12 to 15 kilometers. So, and it is the dividing line between troposphere and the stratosphere. So the polar vortex starts at the upper troposphere, right? Upper troposphere, and it extends into the stratosphere and sometimes continues up to the mesosphere also, right? So what happened? This height continuously keeping going down here, right? So as we go towards the pole, right? So at the pole, the tropopause is about 8 kilometers. So that is between 7 to 9 kilometers. And it is maximum about 15 kilometers at the equatorial region, right? Equatorial region. So that is the basic idea and basic structure, right? So now what happened? The air from the feral cell, this feral cell and the polar cells. You see here, feral cell and polar cell. So this is easterlies, right? And westerlies. Westerlies and here easterlies. So meet at this junction, right? This junction. So that is how much? 60 degrees north, right? So this is called polar front. Polar front. So and also what you find, there is a polar front jet stream. Jet stream. So jet stream is created here, right? So because of this mixing of warm and cold air, right? Warm and cold air. So we have discussed this kind of formation. So this is warm air front and this is cold air front. So and this is the 60 degrees north where jet streams is formed, which is called polar front, right? So now when we are discussing this formation of this particular polar vortex, let's understand how it is created and why it is a low pressure system. Why do we say just that, right? So now what happens? Why it is low pressure system? So that is not the lower atmosphere, it is the upper atmosphere. It can you see this image? It is above the tropopause, right? Tropopause. So it is in the stratosphere and many times also exceeds the stratosphere. So it is in the upper atmosphere as we see here, right? So that is the first point. And then next, when you see this warm front, so it is obviously will go up here, right? Go up here, from here to here. And cold front, it will dominate here, this one, cold front, right? So that is what warm and cold air has this property. So what happens? One branch of this is actually going. So this one actually going here and subsiding down. So, but you see this particular image, right? So, this circulation happens in this particular area, so it goes up and then subsides down on the pole. So that is where it is high pressure, right? So, but another branch reaches tropopause. So, and it goes up to upper atmosphere circulation. So, which is warm air, right? So, in nature, it context to the polar areas. So, this is warm air, which is relatively warmer than what you have cold air in the lower troposphere or atmosphere, right? So, right. Right. So this warm air obviously rise up here, right? And it will go to the polar vortex. So this bed where it will starts doing this circulation, right? So our whirling circulation action. So due to Coriolis, Coriolis, Coriolis force. So it means strongest wear at the poles. So if Coriolis force is strongest at the poles, that warm air that rises up will start going, rotating counter clockwise, right? So in the northern hemisphere. So that is how this polar vortex is formed, and that is important to understand the formation of the polar vortex, right? So, so the formation of polar vortex is that warm front that rises up in the upper atmosphere, and one branch is actually subsiding down, right? So now, why this is fixed to this pole and it is not moving here, here from this pole? Why? So you should remember there is a guard. Where is that? This one. So this is guard, right? So this is gate here, right? That is polar front. So that is polar front jet stream. Sorry. So it is like a guard, right? So it is like a gate. So which does not allow this polar vortex move away. So it is fixed in this particular zone. So remember, at times when this guard is sleeping, what will happen? So for example, in our apartment or in our home or any offices, any other places. So night duty guards, when they are sleeping in that duty time, so thieves or sneaks into those areas, right? So when these weekends, remember jet streams also weekends at certain time period. So that is when this polar vertex gets time to actually intrude into certain areas where you find difficulty in the Midwest US in Canada, right? So where lots of cold winds and negative temperatures are there, right? So you see some of the pictures. Okay. So particular, you see, observe these two diagrams when you have stable polar vortex and you have strong jet stream, right? So it means these positions are fixed here. So it is they're clearly on the northern pole, right? This northern pole, and it is now guided or bounded by this god, right? This one. So that is strong jet streams, right? So this is a normal situation, stable situation, right? So, but at times when there is weakening in the jet streams, these are strong jet streams and weakening jet streams. So when this is loosening up, right? Here. So because you understand that there is a continuous north and southward shift, right? So this one. So of the insulation in temperatures will shift, right? So accordingly, the pressure will also shift. So and remember, jet streams is formed because of the drastic difference between these air masses, right? So because of that, this also weakens at times, and when it weakens, what happens in this cold air warm, right? Air moves, these moves. So cold air moves southwards, that you see in these particular loops only. You see here these loops, right? So that waves called Rossby, Rossby, Rossby waves. So when these Rossby waves are weakens, these Rossby waves are weakened, what happened? It cannot contain this particular air. So and it starts going down, and that is when they starts a problem, and that is where because of this polar vortex oscillation. According to this Arctic oscillation, as we say, it starts happening. So this is where it impacts the land area. You see here this land area, this one. So this land area. So this entire Canada and Midwest of US, so it had lots of freezing temperatures here. And beyond freezing temperatures, so that leads to lots of troubles, right? All of you know about this. So you see, we have two statements here. So jet streams also stronger in the winter. So polar vortices are weakest during summer and strongest during winter, right? So jet streams also strongest in the winter. So, and it is weak during this particular time period when you have in summer, right? When you have in summer. So what will happen? Obviously, when you have weakening and again strong thing happening, there is a fluctuations, or there is an oscillation. So during this anomaly, during fluctuation, so this expands. You see this expands. This expands. And many times you find that due to this weak jet stream. So there is a cold air that rushes from this polar vortex, creating small walls in particular areas, right? It's create small walls. So are small places. So these small places that are entering these entire anomalous systems, it is lead to lots of trouble in the land areas, which is dangerous in terms of situation. So this is the polar vortex. And now okay, tomorrow I will take the class. So that is ozone depletion, right? Ozone depletion. So I will tell in this ozone depletion tomorrow. Okay. Any doubts?